Hi, in this video, you will learn how to obtain the response of a vibrating mechanical system with an input force. This type of motion is called forced vibration because the input serves as the forcing function or the excitation. Unlike the previous topic in which we solved homogeneous differential equation to get the free response, in this topic, we will solve non-homogeneous linear equations with constant coefficients. And we will use the systems approach to separately determine the free response and the forced response. And if we want to know the complete response, we simply add the two. Okay, so if you're ready, let's begin. Forced vibration involves the motion of a mechanical system under the presence of an external force. So this external force would serve as the input to the system. And when we get the forced vibration, we set the initial conditions to 0. So that's just another term for the forced response. But since there is an input to the system, aside from the forced response, we can also get a natural response. Diba? So may makukuha tayong natural response and may makukuha tayong forced response. I-add natin yung dalawa para makuha naman yung complete or yung total response ng system. Now, anong system ang ating imo-model? Meron ulit tayong mass na may kasamang spring at saka damper element. This time, ang pinagkaiba dun sa previously sinosolve natin is, ngayon, may input force na tayo. So, once again, this input force would serve as your excitation, okay? Or forcing function. So, when this mass vibrates, this mass would be displaced. No? At ang displacement niya ay x of t. And this x of t is the output, okay? Now, mathematically, ang output na yan, again, anong nire-represent? Yung solution ng differential equation na nagde-describe dito sa system na ito. Kaya, kinakailangan makapag-formulate muna tayo ng differential equation. And we can do that by applying Newton's second law of motion. Now, applying Newton's second law of motion, which tells us that the net force acting on a mass is equal to the product of the mass times acceleration. What are the forces acting on this mass? First, we have the applied force, F of t. The spring force due to the spring, which is equal to negative kx. And the damping force due to the damper, which is negative bv, because it's proportional to the velocity, is equal to the mass multiplied by the acceleration. So now we have a non-homogeneous differential equation having constant coefficients. Yung mga coefficients natin dyan, yun yung mga parameters na given. Yun yung damping constant, yung spring constant, at saka yung mass. Okay? I can rewrite this equation in terms of only one dependent variable. Kasi dito meron tayong x, v, at saka acceleration. So, pwedeng ang gawin natin dyan is, i-express na lang natin yung lahat in terms of x. Why? Because the velocity is dx over dt and the acceleration is the second derivative of x with respect to t. So, I can rewrite this. No? Sulat natin yan. Magiging m, eto na lang, times a, second derivative ng x with respect to t, kaya mx double dot. Ito ililipat ko sa kabila. So, magiging plus b. Tapos yung velocity, gagawin ko na lang first derivative ng x. Tapos yung kx minus dito, ililipat ko doon, magiging plus uli. Kx. At ang matitira sa right hand side is yung input force or yung forcing function na f of t. Diba? So, now meron na tayong non-homogeneous LCCDE. Now, if I will divide this by m, may makukuha tayo dyan na x double dot plus b over m x dot plus k over mx equals, so yung f of t, i-divide ko ulit ng m. Ayan. So, ito na ngayon yung standard form nung second order LCCDE natin. Yung first term niya or yung leading coefficient ay 1. Diba? So, since ang nakuha nating differential equation ay non-homogeneous, yung makukuha nating general solution ng differential equation na ito na nagre-represent sa x, di ba? X of t ay sum ng dalawang parts. Una, yung xc, complementary function, at pangalawa, yung xp. Okay? So, marunong na kayong kumuha ng xc at saka xp in the previous discussions. However, since application ito, ang gagawin natin is isosolve natin yung general solution na nagre-represent dun sa response ng system gamit yung tinatawag na natural response, xn, at saka forced response, or xf. Okay? So, itong dalawang ito, they are not necessarily the same. In the same way that these two are not identical necessarily. But what is identical is the sum. Kung ano ang makukuha nating sagot sa xc plus xp, dapat yun din ang makukuhang sagot pag inad mo ang natural response at saka forced response. Okay? So once again, itong dalawang ito ang nagre-represent doon sa response ng system. Pag nakita na natin yung equation ng response ng system, pwede na natin siyang i-describe. Diba? Mapipredict na natin kung anong nangyayari dun sa system. Pwede rin natin masabi kung anong klaseng transient response meron yung system, kung yan baga ay underdamped, overdamped, or critically damped. Pero kahit hindi natin isolve yung differential equation, base lang dito sa mga parameters na m, b, at k, pwede na nating malaman yung nature ng transient response ng system. Kasi mula sa m, b, at k, knowing their values, pwede na nating makompute yung damping ratio. At pag alam na natin yung value ng damping ratio, pwede na nating i-classify kung anong klaseng transient response meron siya. Di ba madali lang? Okay. So, mag-solve na tayo ng sample problem. A 10 kg mass is attached to a spring having a spring constant of 140 newtons per meter. So, ilagay na natin dito yung spring constant. K is 140. And the mass is 10 kilograms. The mass is started in motion from the equilibrium position, meaning, nagsimula siya sa x is equal to 0. That's why the initial value of x is 0, again, because it came from the equilibrium position. It has an initial velocity of 1 meter per second. Ayan, v of 0 is 1 meter per second in the upward direction, so positive. And the applied input force, here we have an f of t. The applied input force is 5 sine t. So it's a periodic force kasi sinusoidal siya. Yung ina-apply na force ay periodic, no? Find the natural response, the forced response, and the complete response of the system if the force due to air ay meron tayong damping kasi may air resistance. Kung saan, malalaman natin na ang B, ang value ay 90. Kasi ito yung damping force, negative BV. Okay, so B is 90. Hanapin muna natin yung natural response ng system, yung XN. Sulat natin dito for the natural response. Ano ang differential equation na nagde-describe sa system? If remember, the differential equation is m x double dot plus bx dot plus kx. And since this is natural response, the input must be 0. So, isi-0 natin yan. Homogeneous muna yung equation natin. Pero, i-consider natin itong dalawang initial conditions na given. Now, let us substitute the values. 10, x double dot plus yung b, 90. X dot plus k is 140. X equals 0. So, I can divide both sides by 10 and get x double dot plus 9x dot plus 14x equals 0. Kung saan makakakuha tayo ng auxiliary equation, right? At ang auxiliary equation natin ay m squared plus 9m plus 14. Now, if we want to solve for the roots of that auxiliary equation, gamit na lang tayo ng calcu, mode equation, and quadratic equation solver, 3. So, let us input the coefficients 1, 9, and 14. Okay, so here are the roots, negative 2 and negative 7. we have two distinct roots. That is why our natural response, xn, would have the form c1 e raised to negative 2t plus c2 e raised to negative 7t. Why? Because our roots are real and distinct, negative 2 and negative 7. We can solve for the values of c1 and c2 by imposing the initial condition here. But there are two initial conditions. One requires the velocity, which is the first derivative of xn. That is why we solve first for xn dot. And this xn dot represents the velocity function. So the derivative of this is negative 2 c1 e raised to negative 2t minus 7 e raised to negative 7t. And now, let's impose the initial conditions, which tells us that, ang sabi dyan, ang x of 0 ay 0. Which means that, when t is 0, x is 0. Okay, dito natin yan isa-substitute. So, when t becomes 0, what will be left on the right-hand side is c1 plus c2. So, c1 plus c2 equals, on the other side, ang matitira is yung value ng x na 0. Okay, next. X dot of 0 is equal to 1. Ito yun. Because x dot is v. Dito natin yan isa-substitute. So, dito may matitirang negative 2c1 minus 7. Oops, kulang to. There should be c2 there. c2 equals yung initial velocity na 1. And again, using a calculator, pwede na tayong maghanap ng values ng C1 at C2. Two equations, two unknowns. That's option 1. So let's input the coefficients 1, 1, and the constant 0. Sa pangalawa, meron tayong negative 2, negative 7 at 1. Negative 2, negative 7, and 1. So here are the values of C1 and C2. C1 is 1/5 and the other is negative 1/5. Sulat natin, C1 is 1/5 and C2 is negative 1/5. So we can now write the expression for the natural response. Sulat natin yan. The natural response is xn of t equals, since parehas naman yung 1/5, gawin ko na lang common factor. 1/5 times e raised to negative 2t minus e raised to negative 7t. Okay? So we now have the expression for the natural response. And we can say that since we have two distinct roots, this is an overdamped response, right? Okay, meron tayo ditong overdamped na transient response. Bakit po? Kasi nga case 1 yan, two distinct roots. O, di ba madali lang? Okay. Now, after getting the natural response, we now get the forced response. Para makuha yung forced response, kinakailangan nating i-consider yung input and make all the initial conditions 0. Di ba? So, lagay natin dito for the forced response. Ang i-consider nating differential equation is parehas lang. Kokopyahin lang natin to. Pero ilalagay natin yung input. So, x double dot plus 9x dot plus 14x equals yung input natin na 5. Pero di ba nag-divide tayo dito ng 10? Kaya 5 over 10 yung mangyayari. 5 over 10 is 0.5 times sin t. Tapos yung initial conditions natin, gagawin natin 0. X of 0 is the same as v of 0 and both of them will be equal to 0. Why? That's the condition in solving for the forced response. And because this is non-homogeneous, ang makukuha nating solution ay dalawa. Meron siyang complementary at saka meron siyang xp, right? So unahin natin yung xc. For xc, yung auxiliary equation niya kagaya lang din nung kanina kasi hindi naman magbabago yung equation. So, we will get C1 e raised to negative 2t plus C2 e raised to negative 7t. Now, for the particular integral xp, since we have a sinusoidal input, our x should also have a sinusoidal form. Diba lagi yung sum ng dalawang terms? Yung isa sine, yung isa cosine. So, a sine t plus b cosine t. Now, let's get the first derivative kasi kailangan natin siya dito. Pag mag-equating coefficients tayo, di ba? Sa method of undetermined coefficients, kailangan ng first derivative. The first derivative is a cosine t minus b sine t. And for the second derivative, na kailangan din natin para makuha yung values ng a at b kasi pag nag-substitute tayo dito, we need the second derivative. So the second derivative is negative of a sine t minus b cosine t. Okay. Now we will substitute the first, the second, and this expression for xp here and equate them to 0.5 sine t. So, second derivative, ito yun, negative a sine t minus b cosine t plus 9 times the first derivatives plus 9 times this. So, plus 9a cosine t minus 9b sine t. Next, plus 14x, wherein x is our xp. So, plus 14 sine t plus 14 cosine t equals 0.5 sine t. Okay, so we will simplify this by combining like terms. Ano lahat yung may mga sign? Negative a, negative 9b, at saka 14. Oops, may kulang tayo dito. There should be a here and there should be b there. Okay, 14a minus a is 13a. So we have 13a and minus 9b. All of them multiplied by sine t. Ano naman yung mga terms na may cosine? Negative b, 9a, 14b. Okay. So here, ang makukuha natin is plus 9a. Ito yon. Then 14 minus 1 is 13. Plus 13b. Then multiplied by cosine t. Now, I'll just copy this equals 0.5 sine t. We can now equate the coefficients. This 13a minus 9b must be equal to 0.5. Kasi siya yung coefficient ng sine term sa kabila, right? Next, itong 9a plus 13b should be equal to 0. Bakit? Kasi walang term dito na may cosine. Diba? Tapos, two equations, two unknowns ulit. Palitan lang natin to, magiging 13, tapos negative 9, and 0.5. Second equation, 9, 13, and 0. So finally, meron na tayong values ng A at saka B. No? So ano ang value ng A? Here, A equals 13 over 500 is 0.026. 0.026. And for the value of B, that's negative. Okay, negative 0.018. Negative 0.018. Okay, ayan. So, meron na tayo ngayong values ng A at B. No? May i-substitute na natin yan para sa XP. Diba? At dahil meron na tayong XC at XP, makukuha na natin ngayon yung forced response. Okay, lagay natin dito. XF is ito, C1 e to the negative 2t plus C2 e raised to negative 7t. Tapos, ito, yung A, 0.026 sin t minus 0.018 cosine t. Ayan. So, meron na tayong XF. Now, gagamitin natin yung initial conditions, itong dalawang to, para malaman yung values ng C1 at C2. And before we get C1 and C2, kailangan hanapan muna natin yan ng first derivative. Diba? Okay, first derivative nito, negative 2 C1 e raised to negative 2t minus 7 C2 e raised to negative 7t. Tapos derivative niya. Plus 0.026 cosine t minus, derivative ng cosine is minus, so minus minus, plus 0.018 sine t. Okay. Now, isubstitute na natin ang mga initial conditions. When x of 0 is 0, ang matitira sa expression ng x ay C1 plus C2, ito mawawala kasi sin 0 is 0, minus, dito may matitirang 0.018. Yan, negative. Equals 0. Next, v of 0 is also 0. Ito yung expression sa velocity. Kasi x dot is v. May matitira ditong negative 2c1 minus 7c2. Ito may matitirang plus 0.026. At ito magsisiro kasi sin of 0 is 0. Diba? Equals 0. Ayan. Again, two equations, two unknowns. Calculator lang yan. Palitan natin ang mga naka-input sa calcu ng 1, 1, at saka, oops, pag nilipat sa kabila, magiging positive na yun. 1, 1, and positive 0.018. Yan. Tapos, ito. Pag ito, inilipat natin sa kabila, magne-negative. So, since lahat sila negative, multiply ko na lang ng negative 1 para lahat positive. 2, 7, and 0.026. Now, the values of C1 and C2 are 1 over 50. Okay, ano ba yun? Di ba 0.02 yun? C1 is 0.02 and negative. So, yung C2 ay negative. 1 over 500 is 0.002. Okay. So, we now have the values of C1 and C2. Kaya, pwede na nating maisulat ang forced response. Okay? Sulat natin dito. Sa kabilang page na lang. Therefore, the forced response is C1 is 0.02. 0.02 e raised to negative 2t minus 0.002 e raised to negative 7t. Tapos ito plus 0.026 sin t minus 0.018 cosine t. Yan. Meron na tayong forced response ngayon. At makukuha na natin yung complete response kapag inad natin yung natural at saka forced. Pero bago natin kuhanin ang complete response, suriin muna natin. Yung nakuha kasi natin kaninang natural response ay purely transient. Kung mapapansin nyo, kasi para silang decaying exponentials. And now, yung nakuha nating forced response ay transient din yung unang dalawang terms at may matitirang sinusoidal term dito. Okay? Why? Kasi nga, habang tumatagal itong dalawang terms na ito, since sila ay decaying exponential, mawawala yan. So that means that the forced response contains a portion of the transient response and it contains the steady state response. Okay? So now let us write down the complete response. The total response is x of t, which is the sum of the natural response and the forced response. Yan. Okay. So, mag-a-add tayo ngayon. Kanina, 1/5 yon at ito, negative 1/5. So, mag-add lang tayo. Diba? Mode 1, 1/5. 1/5 is actually 0.2. So, 0.2 plus 0.02, magiging 0.22 lang yun, diba? Nag-calculator pa ako. Alam na naman ang sagot. So, 0.22e raised to negative 2t. Tapos ito, negative 1/5 yun kanina. 0.2 at saka 0.002. So, magiging minus 0.202. e raised to negative 70. Saan ang galing? Yung negative 1/5 kanina, dinagdag ko dito sa negative 0.002. Ito yung sagot. Then, ito, plus 0.026 sin t minus 0.018 cosine t. Yan. So, this is now the complete response. At dyan makikita natin yung dalawa pa ring parts. Itong part na to, since sila ay decaying exponential, yan ang tinatawag na transient response. Ito yun. Transient response because they are decaying exponential. Samantalang itong part na to, as time approaches infinity, sila yung matitira. Kaya yan yung XSS. Ano yan? Yan yung steady state response ng system. Okay? So, kung babalikan natin, ang input dun sa system is sinusoidal. Di ba? Periodic. So, in-expect natin na ang matitira na lang sa steady state, sinusoidal din. Yes, ito yun, no? Ito yung matitira sa steady state na sinusoidal din. Di ba? Yung sine, pag inad mo sa cosine, sinusoidal pa rin siya. Di ba? Madali lang. So, now, tapos na natin i-solve yung problem, no? Nakuha na natin yung complete response at pwede na natin i-describe ang system in terms of the position. Kung gusto mo siyang i-describe in terms of the velocity, kunan mo lang to ng derivative. Di ba? Madali lang? Okay. So, ito yung practice problem, no? Para ikaw ay makapag-practice after mong magpahinga, after mong manood ng video na to, you should solve this problem as a practice. Okay? And you can write the answers on the comment section para magka-compare kayo kung tama ba ang inyong mga sagot or mali. Now, dito sa problem na to, may input tayong sinusoidal, 8 sin 40. Tapos, assuming no air resistance, ano daw yung subsequent motion? So kung wala tayong air resistance, ang mangyayari dyan is walang damping, right? Kasi yung air resistance, yun ang dahilan kung bakit nagkakaroon ng damping. Ngayon, there is a possibility na kung walang air resistance, undamped yung makukuha nating response, di ba? There is a possibility that if your omega, no? Ano ba yung omega natin dyan? Omega ng input, which is 4. Okay? Kapag i-compare mo yan sa omega naught, ano ba yung omega naught? Di ba? Square root of k over m yon. So here we have k and m. Yung m is, ito kasi weight. Remember that weight is equal to mg. So yung gagamitin mo ditong m is w over g. Okay? If ever na mangyari na ang omega ng input ay nag-equal sa omega ng system or yung natural frequency, magkakaroon tayo ng tinatawag na resonance. Okay? Ano ba yung resonance? Resonance is a condition that takes place when the natural frequency of a system, ito yung natural frequency, becomes equal to the excitation frequency. Di ba yung input natin sa yung excitation? Kapag ang excitation ay periodic, at yung pagiging periodic niya nag-match dun sa natural frequency, magkakaroon ng resonance. At kung yan ay undamped, yan ay delikado. Bakit? Kasi kung yan ay isang vibrating mechanical system, yung response niya habang tumatagal ay palaki ng palaki. Okay? So, ma-explain nyo yan kapag sinolve mo yung problem na to. No, mathematically, mapuprove mo kung bakit siya lumalaki ng lumalaki. Pag tiningnan mo yung equation at i-graph mo siya, ang makukuha mong graph dapat ganito. Okay? Now, sir, what if may damping? No? Pero yung omega equal pa rin sa omega naught, hindi mangyayari na ito ay palaki ng palaki. Ang tawag doon ay practical resonance. Hindi mangyayari na yung vibration ay palaki ng palaki kasi darating yung time na pag narating ang steady state, ganito na lang yung makukuha nating response. Sinusoidal, periodic, pero pantay-pantay. Bakit? Because of damping. However, if there is insufficient damping possible, magkaroon pa rin tayo, hindi, no? Mangyayari lang talaga yan kapag ka-undamped yung resonance natin, no? Yung palaki ng palaki. Pero kapag may damping, ito, no? Now, kung maliit naman yung damping, posible na yung system ay mag-collapse din. Bakit? Kasi nga, malakas yung vibration. Although, hindi siya lalaki ng lalaki forever, dahil malakas yung vibration, kung maliit yung damping, posibleng mag-breakdown yung iyong system. Okay? Kaya para sa mga engineer, ang ganyang topic ay mahalaga at ikino-consider. Why? Because it's important in the design of structures. Halimbawa, yung building, no? Yung building kasi na yun ay umuuga because of the hangin, no? yung paghampas ng hangin na yan, it will cause the building to slightly vibrate. Okay? So, dito nagsisimula yung pag-aaral niyan sa pagmomodel ng vibrating mechanical systems. Okay? So, in our next topic, ang i-discuss ko naman ay mga second-order circuits, kung saan yung circuit ay mayroong R, L, at C. At i-compare natin sila. Ano ang analogy sa pagitan ng RLC circuit at ng mga mechanical vibrating systems? Okay? So, until the next video, bye!